Hello. Today we are discussing about GATE 2004 GATE 2004 ECE paper, and which is conducted on 15th February morning. And this question is related to the VLSI mass circuits. The diagram consisting of NMOSs connected in series, and we are going to find the voltage observed at P, Q and R nodes for NMOS transistors which are having threshold voltage of 1 volt. And there are 4 possible options given. We need to find out which is going to be the correct answer. Okay, so before that one we must know that NMOS transistor and PMOS transistors are going to be act as pass transistor. Pass transistor means it is going to be passing the information. It is passing the information. For example, we are going with NMOS transistor, and this is what NMOS transistor. Which will be consisting of 3 terminals: gate, drain and source. Okay, and gate is going to be called as control terminal. By applying the suitable voltage at gate, we can enhance the channel, otherwise we can remove the channel, so that this NMOS can act as either off switch or on switch. So in digital logic we are going with only 2 levels, either high level or low level. So assume that one, if Vg is equal to 0 volts, that is logic 0, then there will be no channel will be created. So by that time it will be act as off switch. It will be act as off switch. So NMOS transistor act as off switch whenever control voltage, that is gate voltage, is at 0 volts. Next, whenever the control voltage, that is gate voltage, is going to be at plus 5 volts, that is plus VDD, by that time there will be a channel created, since we are applying suitable amount of voltage which is greater than threshold voltage. So that channel is created. Then drain and source are going to be shorted together. By that time whatever the information you are connecting at drain, that is going to be connected to the source. So simply then it is acting as on switch. So now whenever it is going to be in the on switch, so whenever Vg is equal to 5 volts, the transistor is going to be act as on switch. And if you are looking at the diagram, all the transistors are going to be connected whose gate voltages are at 5 volts, so all will be in the on condition. Remember that one. Okay, now if it is on, at that time whatever the voltage connected at drain, it is going to be connected to source. But what is the limitation? On switch implies nothing but there is a small limitation is there. On switch is nothing but there is a channel is created, but there is a condition for the creation of channel. So if you want to get a channel at that time, the condition is VGS must be greater than or equal to VT for creation of enhancement of channel. For channel existence, this is a condition. So you must apply minimum of VGS must be equal to VT. So VGS should be minimum of VT at least, that is nothing but minimum possibility. So the value of VGS should be maintained as VT. It will maintain itself as VT whenever it is in the on condition. This is very important, remember it. Now we are coming for this diagram. So let us assume the channel is created and VGS is going to be connected at plus 5 volts. Now if you apply plus 1 volt, at that time what happens is that 1 volt is going to be connected at source or not? It will be, since it is on switch, drain and source are going to be connected, so this will be at plus 1 volt. If you are increasing it to plus 2 will come. If you are increasing it to plus 3 will come. But by that time you must check the condition. Condition for this one is nothing but this is VGS always. Whenever you are increasing drain voltage across this point, as you are increasing drain voltage, source voltage also increases, but gate voltage is at constant. So VGS, if you are going to check, VGS is equal to VG minus VS. whereas this is fixed, and Vs is going to be increasing. So the value of VGS is going to be gets reduced, and it is going to be reducing such that it should maintain minimum of VT, because you must apply that much to maintain it as on switch. So VGS can be equal to 1 volt. So VGS can be equal to 1 volt is nothing but you can write it as VGS, sorry, write it some other way. VGS is equal to here, so Vg minus Vs must be equal to Vt, that is nothing but 1. So from this one you can write it as Vs is equal to Vs maximum is equal to Vg minus Vt. So Vg minus Vt is the maximum voltage source can have. It cannot be more than that one. If it is greater than this one, at that time VGS will be less than VT. By that time the transistor cannot be in the on condition. So we can write for this one, we are going in this way. This is now the condition for this. We can write the condition: source voltage is equal to, okay, it is not visible, source voltage is equal to drain voltage if the condition is nothing but the drain voltage should be less than Vg minus Vt. If it is the drain voltage is less than Vg minus Vt, the entire voltage will appear across source. Otherwise Vs is equal to, it will be maintaining the maximum value Vg minus Vt when Vd is greater than or equal to Vg minus Vt. This is what we are going with. So this is very important whenever you are considering the NMOS. So source voltage is equal to drain voltage. Whatever the drain voltage you are applying, that will appear across source voltage if the drain voltage is less than Vg minus Vt. Otherwise, if drain voltage is going to be equal to Vg minus Vt or more than that one, at that time source voltage cannot reach the drain voltage. By that time it maintains the maximum possible, which is Vg minus Vt. Okay, so here now for this diagram we are going to indicate, always for NMOS higher potential is going to be treated as drain, and this is gate, it is source, again it is drain, source, and it is gate, and again this is gate, drain, and source. Now check this one at P. If you are going to check, always Vg is going to be 5 volts. So we can write the generalized expression for this one: Vg minus Vt for all is going to be Vg minus Vt. Vg minus Vt is always 5 minus 1, which is nothing but 5 minus 1, that is equal to 4 volts, which is common for all the transistors because gate voltage is at 5 volts. So we are going for the condition Vg minus Vt, that is 4 volts. So just you have to check the drain voltage whether it is greater than 4 or less than 4 equal to 4. Okay, so drain voltage for the first transistor, this is for this one, drain voltage is at 5 volts and gate voltage is at 5 volts, but you are going to check only this condition whether the drain voltage is less than or equal to 4 or not. It is greater than 4 volts, so source voltage will maintain voltage at P is equal to Vg minus Vt, which is nothing but 4 volts. And now the drain voltage is going to be at plus 4 volts and gate voltage is at plus 5 volts. So source can reach maximum of this much voltage. So voltage at Q is going to be plus 4 volts. Next, drain voltage of this one, source voltage of that one is nothing but drain voltage of this one, which is at plus 4 volts, and is plus 5 volts. So Vg minus Vt is again 4 volts and drain is also at 4 volts. So source can reach up to maximum of 4 volts. So this is again plus 4 volts. So voltage at node P, Q, R is going to be same as 4 volts, plus 4, plus 4 and plus 4 volts. That's why only, even though you are giving the maximum logic 1, but your source is not reaching the maximum logic 1. That's why That's why NMOS is going to be treated as NMOS passes strong 0. That is nothing but if your drain voltage is 0, source voltage will be 0. But weak 1. Weak 1 is nothing but even though you are giving VDD as 5 volts, that is drain voltage as 5 volts, at source it is passing only 4 volts with respect to this example. So both are going to be treated as high levels, but the difference is nothing but 4 volts is going to be having less noise margin compared to the 5 volts. So that's why this is going to be treated as NMOS can only pass strong 0 but not weak 1. Whereas if you are going for the PMOS is simply opposite of this one. PMOS transmits, that is PMOS passes strong 1 but weak 0. So NMOS advantage which passes strong 0, disadvantage weak 1. PMOS passes strong 1 but weak 0. So combining NMOS and PMOS, and there will be a logic family CMOS which passes strong 0 and strong 1. That's why always pull up circuit of CMOS is always consisting of PMOS transistors, and pull down network always consisting of NMOS transistors. Okay, so the correct option for this is C. Correct option for this one is A, B, C is the correct answer. Thank you.